Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 6 to the power of x is equal to 9. Now what I'm first going to do is I'm going to take the log of both sides. So we have log of 6 to the power of x is equal to log 9. Now, if we have a logarithm in the form log a to the power of b, an important property of logarithms, also known as the power property, states that we can actually move this exponent to the front of the logarithm. So this would be equal to b times log a. So now I'm going to do the same exact thing to log 6 to the power of x. Now we can think of 6 as a and x as b. So I'm going to rewrite this by moving the x to the front of the logarithm. So now this would equal x times log 6 is equal to log 9. Now, to isolate x, I'm going to divide both sides by log 6 so that we can move log 6 to the other side. So now we have x times log 6 divided by log 6 is equal to log 9 divided by log 6. Now, for our left-hand side, these two cancel out, and we simply have x is equal to log 9 divided by log 6. However, if we have a logarithm in the form log a over log b, this is also equal to log base b of a. So we can think of 9 as a and 6 as b, meaning x would equal log base 6 of 9. So this is our answer. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have x to the power of 3 minus x squared equals 100. Now, what we're first going to do is, as you can see, both of these terms have x in them, right? So the best thing to do is to factor out x with the highest degree, which in this case is 2. So we're going to factor out x squared. And that would help us simplify our equation by a lot. So if we factor out x squared, x to the power of 3 divided by x squared, well, that's x to the power of 3 minus 2, which is x, because x to the power of 1 is x, minus x squared divided by x squared is simply 1. So we have x squared times x minus 1, and this equals 100 still. Now what we're going to do is we're going to change 100 into 25 times 4. 100 is equal to 25 times 4. And this is still equal to x squared times x minus 1. Now, this gives us two equations. We would have x squared equals 25, and x minus 1 equals 4. Well, for x squared equals 25, if we do the square root on both sides, we would get, well, the square root of x squared is simply x equals, the square root of 25 is positive or negative 5. So as you can see, this is one solution, and x minus 1 equals 4. Well, we would add 1 on both sides, and if we do that, we get x, these two cancel out, equals 4 plus 1 is 5. However, as you can see, 5 is already one of our solutions, so this is just unnecessary. We already have this as a solution. So we have x equals 5 and negative 5. Now, why don't we plug these two into our equation and see if they are right? Let's first start with 5. So we would have 5 to the power of 3 minus 5 squared equals 100. Now, this would equal, well, 5 to the power of 3 is 125, and minus 5 squared is 25, and 125 minus 25 is 100. So 100 equals 100, and this is right, so 5 is a solution. Now, why don't we plug in negative 5? Plugging in negative 5, we would get negative 5 in parentheses to the power of 3 minus negative 5 to the power of 2 equals 100. Now, negative 5 to the power of 3, well, a negative to the power of an odd number is still going to be negative. And 5 to the power of 3 is 125. So this would be negative 125 minus negative 5 squared is 25. And negative 125 minus 25, well, that's negative 150. And that is not equal to 100, so this is rejected. And 5 is our only correct answer.